Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Welcome to 4.4 and 4.5,
which is solving related rates problems.
I'm Monica.
And I'm Harper.
And this is Student to Student. So how do we solve related rates? Well, it's really important to remember that we need to be able to use the chain rule and implicit differentiation to be able to do related rates. So if you do not remember these sections, make sure you go back to 3.1 and 3.2 and relearn them before moving on to related rates. So we're going to go through an example to help us better understand how to do related rates. So the example is the length of a rectangle is increasing by 3 centimeters per second and the width is decreasing by 5 centimeters per second. How fast is the perimeter of the rectangle changing at the instant that the length is 10 and the width is 8? So here is our rectangle that we're going to be adding information to help us better understand how to do related rates. So what are the steps involved in finding the related rate? First, we have to write an equation relating the variables. Well, if you go back to the second part of the question, it says, how fast is the perimeter of the rectangle changing? So this means we're going to have to use the perimeter equation in this problem. So what is the perimeter equation? Well, it's P equals 2L plus 2W, where L represents the length of the rectangle and W represents the width of the rectangle. So now that we have this equation relating the variables, now we can move on to the second step. Now we have to write down what we've been given in the problem and what we are trying to find. Well, if you go back to the start of the problem, it tells you that the length of the rectangle is increasing by 3 centimeters per second. This means that dl dt equals 3. It also says that the width is decreasing by 5 centimeters per second. This means dw dt equals negative 5 since the width is decreasing. So on the rectangle, it will look like the length increasing by 3 centimeters per second and the width decreasing by negative 5 centimeters per second. It also says that we have to write down what we are trying to find. Well, the second part of the question says, how fast is the perimeter of the rectangle changing? So this means we have to find the rate of P. So that would be dp dt. In this case, dp dt when the length equals 10 and w equals 8. That's what we are trying to find. So now we can move on to the third step. We have to take the derivative with respect to time. And we're taking the derivative of the equation that relates the variables. So in this case, it would be P equals 2L plus 2W. That is the equation that we need to take the derivative of. So taking the derivative of both sides would get you dp dt equals 2dw dt plus 2dl dt. And we're going to use this equation in the next step. The fourth step is to plug in the quantities that we were given. So we just found the derivative, which is dp dt equals 2dw dt plus 2dl dt. And we have to plug in the quantities that we are given. So if you look back to the beginning, we found dl dt and dw dt, which is 3 and negative 5. So all we have to do is to solve for dp dt is to plug those values in. So that's what we do. dp dt equals 2 times negative 5 plus 2 times 3. All we did was plug in the values that we found in the beginning. And we solve for dp dt. dp dt equals negative 4 centimeters per second. And that's our final answer. The negative 4 represents that the perimeter is decreasing at a rate of 4 centimeters per second. The negative represents decreasing.
All right, for our multiple choice, we're going to do a 2012 number 88 question from the AP exam on related rates. And this one is the dreaded shadow. So the question is, a person whose height is 6 feet is walking away from the base of a streetlight along a straight path at a rate of 4 feet per second. If the height of the streetlight is 15 feet, what is the rate at which the person's shadow is lengthening? So I would highly recommend drawing a diagram for this type of problem. So as you can see, we have our street lamp is 15 feet tall. Our person walking is 6 feet tall, and then there's their shadow. So S would be the length of our shadow, and X is the rate at which the person is walking away from the street lamp, which, as we can see here from the question, is 4 feet per second. So that's our first rate is dx dt equals 4 feet per second, and that's the rate at which the person is walking away from the streetlight. Our next rate is ds dt, which is what we're trying to find, the rate at which the person's shadow is lengthening, and s we do not know yet, so that is what we're going to solve for. Next, we look at the equations that we're going to need to make. So for our first one, we have x plus s over 15. The reasoning for that is because of the ratio of the triangles. So as you can see, the large triangle right here with connecting the street lamp and the ground is our big triangle, and then there's another smaller similar triangle that starts at the person and goes the length of s, which is the length of the shadow. So in order to use this proportion, we're going to make the x plus s, which is the full bottom length, over 15 equal to the s, the length of our shadow, over 6. And so those will be proportional, so therefore we can solve for our x. So then that simplifies, when you cross multiply, that simplifies to 6x plus 6s equals 15s. And then if we simplify that again, we get our 6x equals 9s. So once we have that equation, we can move to the derivative. So now we need to take the derivative of the equation that we just made. So that'll be d6x dt equals d9s dt. And then when we take the derivative of that, it turns into 6 dx dt equals 9 ds dt. So now we can substitute and solve. So we take our known value, which is the dx dt from before. We said that was 4 feet per second, so we can plug that in next to the 6. So now we have 6 times 4 equals 9 ds dt, and remember, ds dt is our unknown. And then that will turn into 24 equals ds dt, and then you just divide the 9 over. So you get 24 over 9 equals our ds dt, and then that simplified will give us an answer of b, which is 2.667 feet per second. And again, that is the rate at which the person's shadow is lengthening.
This was the 2016 Related Rates FRQ number 5C, aka the funnel. So what is the problem? The inside of a funnel of height 10 inches has circular cross-sections, as shown in the figure above. At height h, the radius of the funnel is given by r equals 1/20 3 plus h squared. So this is a picture of the funnel that we're going to be dealing with today. So for part C, the funnel contains liquid that is draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? So on our picture, we can see that the funnel is draining liquid. And what exactly do we need to do to solve this problem? Well, we know we have to take a derivative, and we're given the equation for the radius. So we need to take the derivative of the radius with respect to time. So taking the derivative of both sides will get you dr dt equals 1/20 2h times dh dt by using the chain rule. So now we need to plug in what we've been given. So we know that the height is 3 inches, so we can plug that in for h. We also were given the radius, we were given dr dt, which is negative 1/5 inch per second. So we can plug both of those values into the equation. So dr dt is negative 1/5, and plugging in h for 3 will get you 3/10. So now we're left with dh dt. So now we need to solve for dh dt to find the rate of change of the height of the liquid with respect to time. So solving this equation will get you dh dt equaling negative 1/5 times 10/3. Solving that will get you negative 2/3 inches per second. And that's your final answer. So if we're looking at the scoring guidelines, we can see that there's 2 points given for the chain rule. So just for using the chain rule correctly, you get 2 points. So it's important to remember when taking derivatives to use the chain rule. Otherwise, you could lose a lot of points. You also get 1 point just for your answer. This was 4.4 and 4.5.
Solving related rates.
We out!